All right, I had to switch up the camera a little bit here, but we'll start by drawing land down at the bottom. Now on your land, label it land. You can draw a little tree if you'd like. Keep it pretty small. You can draw a little animal if you're into that. Okay. What is our first layer of the atmosphere? Well, that would be the troposphere. Doesn't have to be a perfectly straight line. Let's label troposphere at the top. There we go, troposphere. And within our troposphere, this is where you're going to have your clouds. So you can draw some puffy clouds, some cumulus clouds. If you want to draw a little lightning bolt or two, you can. Awesome. If you want to draw a little rain, go for it. So this is the troposphere, our first layer. Also, too, any passenger planes, most of your passenger planes are going to be found here in the troposphere. So if you want to test your artistic ability, you can draw a little airplane here. We'll draw the front end, a wing, looping back, another wing here, looping back. Oh yeah, thrusters. Okay, there's our airplane. All right, now let's move on to our next layer of the atmosphere, which we call the stratosphere. Stratosphere. And within our stratosphere, there's an accumulation of a certain molecule. It starts with the letter O. You may have heard it before. It's called ozone. Now, if you're flying up into space, you're not going to all of a sudden see a layer of some different air molecules in the air. It's completely invisible, the ozone is. But the way we can showcase it or illustrate it would be to draw kind of a squiggly line like this. And then we'll label this squiggly line after as ozone. So this is ozone. Ozone is almost like oxygen that we breathe in. Oxygen that we breathe in is O2. Ozone is O3, so 3 oxygen molecules. So next up, after we get through the stratosphere, we'll find ourselves in the coldest layer of them all. It's also our middle layer. It is the mesosphere. Mesosphere, since it is the coldest, however you want to showcase that, you can maybe draw a snowman. You could draw snowflake, if you want to draw better snowflakes than that. But let's just write that it is the coldest. How cold? Right around negative 100 degrees Celsius. Okay, also too, this is kind of our first layer where you have a decent amount of air molecules accumulating here. Stratosphere, even more air molecules, and then the troposphere, the most, which also means it's the most air pressure. We're getting less and less pressure, less and less air molecules as you head out towards space. So the mesosphere is actually kind of our one of our lines of defense, especially against meteors. So what we'll draw here is a meteor coming in. I'm going to draw that meteor is cracked, but it came from outer space. And this is typically the layer where your meteors are going to be burning up. It's where they first encounter a good amount of friction to where they can start to burn. When you're out in these other layers, the thermosphere and exosphere, which we haven't talked about yet, but there's really not much for air molecules there to cause really any air resistance and that friction. So meteoroids or meteors would burn up right here. Okay, now let's go to the next layer, which is our hottest layer. So we go from coldest to hottest. This next layer is called the thermosphere. Okay, the thermosphere. Now, if you want to draw some sort of flames, you can, oh boy, yikes. These are flames. Oh man. All right, there's my wonderful flames. If you can't tell that they're flames, you might want to say that this is the hottest layer. How hot? Right around 2,000 degrees Fahrenheit, or Celsius, pardon me. So hottest layer. Also too, in this layer, you're gonna see those kind of the ions within the air get excited by the sun's energy, and it shows off some cool colors. So this is actually where you get those auroras. So however you want to showcase some auroras, some wispy lines, if you've got colored pencils, that'd be awesome, but label this an aurora. Okay, or auroras, we'll go plural. All right, pretty good for the thermosphere. We'll then go one more layer out, and our next layer is the exosphere. And you don't even have to put a line on top of this layer if you don't want to. Really, you're not going to see that line. It's just wherever you run out of air molecules. Where the air molecules stop, that's where space begins. But this will be the exosphere. I'll make sure I can get it on the page. Right here. Exosphere. Okay, our exosphere is our outermost layer. One thing we haven't shown yet is kind of where satellites are orbiting. A lot of your satellites can orbit here in the thermosphere. Depends on the size of them. The smaller the satellite, the closer it can be orbiting. Obviously, if you have a larger mass, it's going to get sucked into the Earth. So those larger mass or the bigger satellites are going to have to be further away from Earth so they don't get pulled all the way in and smash into Earth. So our satellite, let's draw one right over here. Now, if you want to draw a satellite a different way, you can. I'm just going to draw kind of the main body of it, a couple arms coming off, and then here's kind of your disk, or the actual satellite part that can receive signals. All right, cool. And now let's go to talking about air molecules. So over on the left side, I have a good amount of space over here. You can do it really anywhere, but let's showcase how many air molecules are present. Now, I told you before, the closer you get to the land, or down here in the troposphere, you're gonna have the most amount of air molecules. So the way I'm gonna showcase that is just with dots. And so hopefully the camera doesn't get too shaky while I'm doing this. But in the troposphere, you would have by far the most amount of air molecules, the most amount of dots. You would also experience the most amount of air pressure down here, okay? And then if you go even below land level or sea level, then you'd experience even more pressure. The atoms are able to pack themselves even tighter, greater density. So let's go out into space now. We've just drawn our troposphere air molecules as much as you can. And now into the stratosphere. Still a good amount, but we're going to be losing air molecules. I mean, we're beyond the top of Mount Everest. Top of Mount Everest almost reaches the stratosphere, but not quite. But even at the top of Mount Everest, it's slim pickings for the air molecules. Out in the mesosphere, even less. Thermosphere, less. Exosphere, not much at all. So show some sort of a gradient as you go from abundant or a lot of them to very little. Okay. One other thing we can point out too is temperature in the troposphere. I'm just going to showcase it by a line either going up and to the left or to the right. Our first one, or actually let's write down here, let's say high pressure. High pressure, and then therefore out here, low pressure. Okay. And you can label this out here space if you want to. You got the sun. You can't see that, but okay. Let's get back to the temperature. if you see the line going to the left, like it does in the troposphere, that just means as you go up into the troposphere, our temperature goes down. It gets colder as you go up. Then in the stratosphere, it goes back the other way. In the stratosphere, as you go up, it gets warmer. Then in the mesosphere, back the opposite way. As you go up, it gets colder. And then the thermosphere, our hottest layer, this is where it's going to get the warmest. And then the exosphere, it's because there's so little air molecules out here, one of those singular air molecules could be certainly very excited by the sun's radiation, and that individual molecule would have a very high temperature or high kinetic energy. It's moving around a lot. But you as a person, if you are up here in the exosphere, there's very little air molecules, so you're not going to have many collisions. So it would feel cold if you're not in a spacesuit, which you'll need to be in a spacesuit. But we'll just continue that line and keep that going up. Okay, and I think we will stop there. Good work.